Hi, we are talking today, we're going to skip lesson 12 because it's basically just a review of what you've already learned, and we're going to move on to lesson 13, implicit differentiation. Well, what is implicit differentiation? Implicit differentiation is finding the derivative of x the derivative of y, with respect to x, or finding dy over dx. You've already been doing this actually. The difference with implicit differentiation is that we're going to have more complicated functions. So I'm just going to go through a lot of examples. This video is going to be a little longer than usual. If you feel like you understand it after a few examples, you certainly don't have to finish watching, but I am going to do about maybe 8 examples so that you can kind of see this in action. So here we're finding dy over dx for x squared minus y squared equals 16 at negative 5, 3. Usually, if we were going to find a derivative, we would actually have to solve for y first and then find our derivative. But with implicit differentiation, you don't have to do that. You can actually just take the derivative of each variable and kind of proceed as usual. So I'm going to do that now. We have x squared minus y squared equals 16. First, I'm going to take the derivative of x squared. That's equal to 2x. And because I'm finding this derivative with respect to x, I could, and I'm going to show you the long way here, I'm going to multiply by dx over dx. Okay? So I found the derivative of my first term. Minus the derivative of my second term is 2y times dy over dx, because I'm finding this with respect to x, right, is equal to 0. So now you can see actually that dx over dx is equal to 1. So I'm going to rewrite this again as 2x minus 2y times dy over dx is equal to 0. This is the exact same information. Now, the thing that we want to do when we're finding our derivative, the derivative of y with respect to x, we're trying to isolate the derivative, that dy over dx. So I subtract 2y from both sides, or 2x, excuse me. So I get negative 2y times dy over dx is equal to negative 2x. Then I have dy over dx is equal to negative 2x over negative 2y is just going to be x over y. That's the actual derivative. Now, we were actually asked to find this at negative 5, 3, so we're going to do that now. We'll dy over dx at negative 5, 3 is equal to negative 5 over 3. And this is it. This is our derivative. We found our final answer. So again, I think that this is going to become easier as you go through it. I'm just going to do quite a lot of examples so you can see it in action, and hopefully that will help it make sense. So let's do another one. We want to find dy over dx for xy plus y is equal to 8 at 3, 2. Well, first I need to find my derivative. So I've got xy plus y is equal to 8. Looks like I'm going to have to use the product rule here. So I have the first x times the derivative of the second. The derivative of y is going to be dy over dx plus the second y times the derivative of the first is just going to be 1. And sometimes I like to put all this in a bracket so I can see what I did here. Plus y, not plus y, excuse me, plus dy over dx, I need to take the derivative of that, is equal to 0. All right? So now I'm going to move that y. So I have x dy dx plus dy dx is equal to negative y. And you should factor out a dy dx. So you're left with x plus 1 equal to negative y. So finally, dy, hopefully you can see this right now, dy over dx is equal to negative y over x plus 1. And that's our derivative. That's the general derivative, but we were asked to find this at 3, 2. So dy over dx at the point 3, 2 is equal to negative 2 over 3 plus 1, which is negative 2 over 4, which is a negative 1/2. That's our final answer. Hopefully that made sense and was pretty clear. I'm going to do some more complicated examples as we go on here, so you can kind of see what's going on. So let's do another. We're asked to differentiate x plus 3xy minus 2y squared is equal to 2. Well, the derivative of x is just going to be 1, right? It's actually going to be dx over dx, but we know that that's equal to 1. Plus, I am going to have to use some product rule here. 3x times dy over dx plus y times 3 minus, and here I'm going to have to use, I guess, chain rule, or just basic exponential power rule it's called, minus 4y times dy over dx is equal to 0. So I have 3x dy dx minus 4y dy dx is equal to, it looks like I'm going to have a negative 1 minus 3y if I've combined those appropriately. So I can factor out 3x minus 4y times dy over dx equal to negative 1 minus 3y. So our derivative dy over dx is equal to negative 1 minus 3y over 3x minus 4y. And that's actually our final answer. If you want to rewrite this, you can. I mean, this is equal to, like, if I took out a negative 1, I would have 1 plus 3y over 4y minus 3x. That's the same thing, but basically that's it. We weren't asked to differentiate at this particular point, so we are actually done with this problem. All right, let's find dy over dx for this next one. Y cubed plus 5y squared minus 5y. Oops, did I miss a part? I totally did. Let me rewrite this here. Woo. All right, it's supposed to be y cubed plus 5y squared minus 5y minus x squared equals negative 4. We wouldn't want to miss all the fun there in the middle, would we? All right, so let's find our derivative. We're going to have 3y squared times dy over dx plus 10y times dy over dx minus 5 times dy over dx minus 2x equals 0. A lot of fun things here. I'm actually going to kind of speed it up a little bit if I can. I've got dy over dx times 3y squared plus 10y minus 5 is equal to 2x. I think that looks correct. So dy over dx is equal to 2x over 3y squared plus 10y minus 5. Pretty good? Gosh, my x's always look like v's. So weird. All right. Next, find dy over dx for x ln of y is equal to e cubed. So we've got x times the natural log of y is equal to e cubed. Okay, so we're going to use product rule here. We have the first times the derivative of the second plus the second times the derivative of the first is just 1 is equal to, e cubed is actually a number, so that's 0. So now I have x over y times dy over dx is equal to negative natural log of y. So dy over dx is equal to a negative y natural log of y all over x. That's kind of a pretty one once it kind of gets done there. All right, let's do another. So find y prime for y e to the x equals 3 pi. I almost said 3x again. So we're going to use product rule. So first times the derivative of the second is going just to be e to the x times the derivative of x is dx over dx plus e to the x times dy over dx is equal to 3 pi is just a number, so 0. So now I'm going to rewrite this. I have e to the x times dy over dx is equal to a negative y e to the x. So dy over dx is equal to negative y e to the x over e to the x. These clearly cancel out. So our derivative dy over dx is equal to negative y. Now, throughout this, I used dy over dx. We were asked to find y prime. You know that that notation is actually the same. I personally like to use dy over dx when I'm doing implicit differentiation, mostly because I think that that y prime, at least with my handwriting, sometimes I miss it. And so I just try to be a little more careful with it and keep it in there to keep things clear for myself. So let's do 2 more final examples. All right, we are asked to differentiate. Ooh, a little bit of trig. Trig's always fun. Cosine of xy is equal to x plus 3y. Well, the derivative of cosine is negative sine of xy times, and we're going to have to use product rule here. We're going to take the first times the derivative of the second, plus the second times the derivative of the first, I guess is just 1, is equal to 1 plus 3 dy over dx. Looks like maybe this is the first one we've done where we now ended up with dy over dx on 2 sides here. So, oh, this is getting really ugly, but I'm going to do it anyway. So we have negative x sine of xy minus y sine of xy is equal to 1 plus 3. Oh, I missed something here, didn't I? I need to have a dy dx right here, don't I? Plus 3 dy over dx. Okay. So now I'm going to move some stuff over. I've got negative x sine of xy dy over dx minus 3 dy over dx is equal to 1 plus y sine of xy. I think that's so far so good. So now I can pull out, I'm going to have a negative x sine of xy minus 3 times dy over dx is equal to 1 plus y sine of xy. So dy over dx is equal to 1 plus y sine of xy divided by a negative x sine of xy minus 3. And I guess if you wanted to, you could have rearranged stuff here, but that's basically correct. All right, let's do a final one here. We want to differentiate the natural log of xy is equal to the tangent inverse of x. Oh, some of that inverse stuff. It's so much fun. So the natural log, I'm going to rewrite this as the natural log of x plus the natural log of y is equal to tangent inverse of x. That's going to make life a little bit easier for us. So natural log of x, the derivative of that's 1 over x, plus where the derivative of natural log of y is 1 over y times dy over dx is equal to the derivative of tangent inverse of x is 1 over 1 plus x squared. So now I have 1 over y times dy over dx is equal to 1 over 1 plus x squared minus 1 over x. So dy over dx is equal to y times, oh, I guess I could 1 plus x squared minus 1 over x. I don't really feel like finding a common denominator, but I guess I could, right? So I've got y times x minus 1 minus x squared over x times 1 plus x squared, right? Yes, something like that. And you could keep simplifying if you wanted to, but basically that's it. Okay, one final thing. For those of you who've watched to the end of the video, you get a special surprise. I'm going to tell you right now that the name of my childhood dog was Cracker Jacks. It's a type of American like popcorn, caramel corn candy thing. So that's the name of my childhood dog. This could be a bonus question on your assessment, depending on how I'm feeling that day. And that's it. I'm going to erase that right now. It will not be in your notes. Hopefully you remembered. Hopefully you had a great day and that you understand implicit differentiation pretty well. And I look forward to seeing you in class. Bye!